Hello and welcome to this overview of the Acconeer Exploration Tool. We will take you through all the basic settings and tell you a bit about how each setting affects your radar performance. Today we will focus on the Sparse IQ Service. Let's begin. In the top right corner we have the control section. If you have flashed and connected your sensor correctly, the Start Measurement button will be blue. You can click the button to start your measurement. When you have finished your measurement, you click the Stop button. To view your current configuration in the Resource Calculator, you can click the button View in Resource Calculator. Since I haven't changed any settings today, we will start with the default settings. In the section below, the control section, you will find the metadata. Here, the metadata for your current configuration will be displayed. You can see your frame data length, calibration temperature, your max sweep rate, and if high-speed mode is activated or not. In the section below, we find the performance estimates. Here you will find your estimated average current. When you change your sensor settings, your estimated average current will change accordingly. In the section below, we have the processor parameters. Since this is the basic Sparse IQ service, we only have a single processor parameter. The processor parameter is the amplitude method. In other words, how we calculate the amplitude. We have three different choices. Either coherent, where we consider the phase, non-coherent, where we don't consider the phase of the data, and the FFT max, where we get the amplitude from our highest velocity component. Below, we have the session parameters. Here, we can choose which sensor to use. Since I only have one sensor connected, we can only choose sensor 1. The next parameter is the update rate. If we don't limit the update rate, we will have the highest limit possible. However, if we choose to limit the update rate, we will limit the rate on the server. The next section is the sensor parameters. Here we can choose sweeps per frame, so we can choose how many sweeps we'll have in each frame. The next parameter is the sweep rate. Here we can choose to limit the sweep rate to a certain frequency, or we can choose to have an unlimited sweep rate, which will make the sweep rate go as fast as possible. Below we have the frame rate. The frame rate works in the same way as the sweep rate, but instead of limited the sweeps, we limit the frequency of the frames. Then we have intersweep idle state. The intersweep idle state is the state the sensor idles in between each sweep in a frame. Idle state deep sleep is the deepest state where as much of the sensor hardware as possible is shut down. And the idle state ready is the lightest state, where most of the sensor hardware is kept on. Deep sleep is the slowest to transition from, while ready is the fastest. Below this parameter, we have instead the interframe idle state. This must be deeper or the same as the intersweep idle state. Below this, we have two checkboxes. The first one reads continuous sweep mode. By checking this box, you assure that the time between each sweep in a frame is the same as the time between the last sweep in the frame and the first sweep in the next frame. One could of course set the frame rate to approximately satisfy this condition, but using continuous sweep mode is more precise. Also note that there is no use to apply the continuous sweep mode if you only have one sweep per frame with a fixed frame rate, since you already have a continuous stream of data. The second checkbox reads double buffering. If you enable this, the sensor buffer will be split in two halves, reducing the maximum number of samples. A frame can be read while sampling is done in the other buffer. This can be used when we want to sample at a very high rate. For example, often when we use continuous sweep mode. Now we come to the last section, the subsweep parameters. As you can see, I only have one subsweep available right now. But if I want several subsweeps, I can click the plus to the right. But we'll start with only one subsweep. First, we have a little box, approximate selected range. This box will automatically display which range you have chosen in your current configuration. The first thing that you can change is the start point. You set the start point from where you want to start your measurement. Each point corresponds to 2.5 millimeters. Say I want to start 1 centimeter from my sensor, I can put start point 4. By changing the next parameter's number of points, you can choose how many points you want to be in your sweep. The next parameter, step length, will determine how many steps of 2.5 millimeters will be between each of your points. The step length must be a divisor or multiple of 24. Below we have HVAS, which is an acronym for Hardware Accelerated Average Samples. You can choose how many HVAS you want. The more HVAS you have, the better SNR you get for your signal. However, each measurement will take longer time, which will increase your power consumption. The last parameter is our profile. Here we can choose the length of our pulse, where profile 1 is the shortest and profile 5 is the longest. The shorter the pulse, the better distance resolution you will get, but worse SNR. By choosing a longer profile, you will get better SNR, but a worse distance resolution. In the middle section, we have 3 different graphs. The top graph will show your amplitude. The middle graph will show your phase. And the final graph, the one at the bottom, will show your velocity on the y-axis and your distance on your x-axis. And now we have come to the end of this video. Thank you for watching.